Example 1. Let f of x equal the function x squared minus 5. Let's find and simplify f of 2. What does this mean? This means that when x is 2, we want to find the corresponding value for y. What would the y value be? How do we determine that? Well, if we're given the function as an equation, we simply take our equation, and everywhere we see an x in that equation, we're going to replace it with the value 2. So we take 2 and substitute it in for x, and that gives us 2 squared minus 5, which is simply 4 minus 5, and 4 minus 5 is negative 1. We then say that f of 2 is negative 1. In other words, when x is 2, y is negative 1. Let's look at example 1b. Again, considering the function f of x equals x squared minus 5, find and simplify f of negative 1. This time, our x value is negative 1. We want to substitute it into our function and find the corresponding value for y. How do we do that? We take negative 1 and replace x in our equation with negative 1. So let's do that. F of negative 1 is simply negative 1 squared minus 5. Let's simplify. Negative 1 squared is negative 1 times negative 1, which is just positive 1. And 1 minus 5 is negative 4. This tells us that f of negative 1 is negative 4, which means when x is negative 1, y is negative 4. That completes example 1b. Example 1c. F of x equals x squared minus 5. Find and simplify f of 0. We work this example just like the preceding examples. This time we're going to be substituting 0 in place of x, and then finding the y value that corresponds to when x is 0. So we rewrite our function, but replace x with 0. That is, f of 0 equals 0 squared minus 5. Let's continue to simplify. 0 squared is simply 0, and 0 minus 5 is negative 5. Restated, this tells us that f of 0 equals negative 5. That completes example 1c. Example 1d. This time, we're asked to take our function f of x equals x squared minus 5 and find f of q. That's a little strange. Q's not a number, it's a letter. But the way we evaluate this is the same as we did the previous examples. Instead of putting a number in for x, we're simply going to replace x with the letter q. In other words, we're asking ourselves, when q is put into x in our domain, what is the corresponding output of y? Let's see. Take our equation, and everywhere we see an x, replace it with the letter q. That's going to give us that f of q equals q squared minus 5. Can we simplify this any farther? No, there's no terms to collect. Nothing will simplify. So f of q is simply the expression q squared minus 5. In other words, when we input q in for x, we get out q squared minus 5. Example 1e. Let f of x equal x squared minus 5. Find f of q plus 1. This time, we're going to replace x with the expression q plus 1. So everywhere we see an x in our function, we're going to rewrite q plus 1. That is, f of q plus 1 is equal to, and in place of x, we simply write q plus 1 squared minus 5. This we can simplify a little farther using some algebra skills. q plus 1 squared. Well, q plus 1 squared, let me do it off to the side. Recall, q plus 1 squared is the same thing as taking the polynomial q plus 1 times q plus 1. And q plus 1 times q plus 1, we would multiply or FOIL out. That would give us q squared plus 1q plus another q plus 1. Right? First, outer, inner, last. And when we put this together, that's simply q squared plus 2q plus 1 minus 5. That tells us that f of q plus 1 is simply equal to the expression q squared plus 2q, and notice I'll take 1 minus 5 and get negative 4. So f of q is simply q squared plus 2q minus 4. We finish example 1 with 1f. F of 0. Oh, this is tricky. So what must we do to evaluate this expression? Well, let's start with the inside first, and let's evaluate f of 0. F of 0 says when we plug 0 in for x into our original function, what would the y value be that we get that corresponds? So let's take 0 and plug it into our initial function. That gives us 0 squared minus 5, and 0 squared minus 5 is the same as 0 minus 5, which is just negative 5. That tells us that f of 0 is simply negative 5. So let's replace it into our original expression. We have f of 0, which we've just discovered is f of, and f of 0 is negative 5. So we have f of negative 5. Now we repeat and plug negative 5 back into our function f again. That's what f of negative 5 says. So when x is negative 5, what's our y value? Well, to evaluate this, we take negative 5 and substitute it back into our original function. F of negative 5, that equals, and place negative 5 into our function in place of x, and that gives us negative 5 is negative 5 squared minus 5. And what's that simplify as? Negative 5 squared is negative 5 times negative 5, which is just positive 25, minus 5, and 25 minus 5 is 20. Phew! So what does that tell us to summarize? That tells us that f of 0 is equivalent to taking f of negative 5, since f of 0 just turned out to be negative 5, and f of negative 5 is equal to 20. In other words, f of 0 is simply 20. That was a doozy. Let's look at examples now where our functions are not equations but rather sets or graphs. Let's now look at a different type of example. Example 2. Let f be the function defined by the set of ordered pairs negative 2, 7, negative 1, 10, 0, 6, 1, 7, 2, negative 2. We are asked to find f of negative 1. What does this mean? Let's dissect it. F of negative 1 means when x is negative 1, what is the corresponding y value? What is this equal to? So let's look up in our set of points, and let's find a point that has the x value being negative 1. And notice, this is the point right here, negative 1, 10. When x is negative 1, y is 10. And therefore, f of negative 1 simply is the y value 10. It says when x is negative 1, the corresponding y value is 10. That's it. Example 2b. Find all x values that make f of x equal to 7. Now we're referring to the same set as we just did in the previous example. Our set is the ordered pairs -2, 7, -1, 10, 0, 6, 1, 7, and 2, -2. We want to find all x values that make f of x equal to 7. What does that mean? Let's look at this a little closer. When f of x equals 7, that means that we have an x value that corresponds to a y value being 7. So we want to go into our set and look for all the ordered pairs where the y value is 7. Notice, this right here has a y value of being 7, and this point right here has a y value being 7. There are two ordered pairs that satisfy the condition that our function is equal to 7. So what are the x values that pertain? So the first x value is when x is -2, and the second x value is when x is 1. That is, there are two x values that will make f of x equal to 7, which we could restate as f of -2 equals 7 and f of 1 equals 7. Let's take a look at another example. Let's now look at an example where a function is in graph form. Example 3. Use the given graph of the function f to solve the problem. Example 3a. Find f of 0. Alrighty, f of 0, what does this mean? F of 0 means when x is 0, what is the corresponding value for y? So let's take a look at our graph. There are infinitely many points on this curve. We are specifically looking for the place where x is 0. So looking along your x-axis, x is 0 right here. And the point corresponding to when x is 0 is this point right here on the curve. That's the point 0 for x, -1 for y. So, on the graph, when x is 0, our y value is simply -1. And so we would write that f of 0 is -1. When our x value is 0, the corresponding y value is -1. Does that make sense? Example 3b. Using the same graph of the function f, find f of 2. What is this problem asking us? Well, it's asking us when x is 2, the input, what is the corresponding y value, our output? To determine this on the graph, we again look to our graph and find a point where x is 2 and then locate the corresponding y value. So let's go to our x-axis. When x is 2, we're right here. And the point on the function that corresponds to x being 2 is this point right here. This is the point identified by 2 for x and 3 for y. This is the point on the function. So when x is 2, the value of our function, the y value, is simply 3. That means that f of 2 equals 3. This brings us to our last example in this topic. Example 3c. Again, use the given graph of the function f to solve the following problem. Find all x values that make f of x equal to 8. What is this asking us to do? Well, let's look at this again. We are looking for all the values of x that we can substitute into this notation so that we get back a value of 8 for y. In other words, we're going to look for all the points on the graph where our y values are 8 and then find the corresponding x values. So let's go to the graph and let's locate where y is 8. Y is 8 right here. There are actually 2 points on the curve that correspond to y being 8. This point here on the left and this point here on the right. Now the point on the left, that is actually the point -3 for x 8 for y. Do you see that? That's 8 for y and negative 3 for x. And this point here, well, the x value is 3 and the y value is 8. These two are the only points on this curve where your y value is equal to 8. So what are the x values that will make this true? Well, there's clearly two of them. Either x is negative 3 or x is 3. Similarly, we could write that f of negative 3 is 8 and f of 3 is 8. Perfect. That ends our discussion and topic on function notation and function evaluation.